So in this video we're going to show you how I built this covered deck from scratch. So here's a brief shot of the finished product. Now back to the start. Here we are at the start of our deck and veranda, conservatory, whatever you want to call it, project. So the idea is to cover that area there with timber decking, and there'll be timber posts spaced out along the side. You can see some of those squares on the ground are where the posts are going to go, and they will support a roof. So there'll be a multi-wall polycarbonate roof sloping over the deck area. So the deck will extend to cover this area of green grass on the left, and obviously the concrete there that you see those flower pots on will also be covered by the deck, and it'll come out as far as these squares I've marked on the ground. So I'm about to sink concrete pillars as foundations for the upright posts. So there'll be one here at the edge, two in the centre and one at the end. And there will also be a similar few posts up here supporting it on the side. I haven't marked the ground for those yet. So these are spaced at 2 metre intervals. The squares are 30 centimetres on a side, and my intention is to go 30 centimetres deep. The ground here in this garden is very firm, very dense soil, so that depth should be adequate. There won't be a lot of weight. It's only a lightweight polycarbonate roof that's on it. So you can just see down here I've started one of the holes. I started with the shovel, and I created nice square cuts to have a nice clean square edge. Then I have a 6-inch auger, 150mm auger there, so I use that to penetrate the ground down to about 6 inches depth, and was able to subtract or withdraw that square of grass that you see lying there in one go. So now I just need to deepen that hole down to 1 foot. When I've all the holes dug, I'll be putting in concrete. I'll be bringing it proud of the ground by about 1 inch. That's so that it's above the area where water will be lying on the ground in wet weather, and then the timber post will sit on top of that concrete. So I'll be building a small 1-inch high timber frame around this hole to allow me to raise the concrete and to get a level surface on the top of it. That's all for now. Okay, so I've made up this frame and placed it around the holes to allow me to make sure that everything is level. So not only do I want the top of each concrete pad to be level, I also want the 4 pads to be level with each other in a straight line, so that my deck is flat and level, not sloping. And there is a slight slope as you look at it here. This is the high end I'm standing at, and there is a slight slope as we go towards the far end, so I've had to pad out the underneath of the frame with little pieces of wood to make sure that it's raised at the far end and everything is level from end to end. So the holes are dug, and I've cut a little 35mm high frame of timber around each hole, and the concrete will be levelled off at the top of that, which means that when the timber is taken away, the concrete will be 1 inch above ground level, so rainwater that's on the top of the ground won't be sitting on top of the concrete. It should run off the concrete, and so the end of the timber posts should be prevented from being standing in water the whole time. So here's my spirit level. So it's important you run along the line from end to end, and you make sure that everything is level. And you also check from side to side across each hole to show that it's level there too, and so on down to the end. We've got nice clean holes there, squared off, so each one is 30mm square or cube rather, so it's a cubic foot essentially. we'll see what happens when we start pouring concrete tomorrow. So we're about ready to start mixing the concrete for the foundation pads. The classic mix here for general purpose concrete is 1 part cement, 2 parts sand, 3 parts aggregate, or what most people call gravel. So that's what we have here. We've 1 shovel full of sand, 1 shovel full of cement, 2 shovels of sand and 3 shovels of gravel. I'm going to dry mix these ingredients, and then I'm going to add water into a well in the middle and mix them up until we have a good consistency. So I have 2 pads filled now, 2 concrete foundation pads. This one was levelled off with the timber, but it's been about an hour now since it was levelled, and the sun is shining, so it has shrank back a small bit below the level of the timber, but presumably if I level all of them the same way, then they'll all suffer the same amount of shrinkage, so I'll still end up with level pads. Here's one that's just been levelled about 10 minutes ago, so it's still quite wet and quite level with the timber, but I presume it's also going to shrink a little when the sunlight evaporates water off the surface of it. So here's the finished foundation pads with the timber frame removed. We need to leave them now for at least a week for the concrete to fully harden before we start drilling any holes in them to support the framework. These guys down here are a little bit higher up because the ground is lower here, so in order to get a level surface with the other pads, these lower 2 here had to be raised up to a higher level. But when I run a level line across the 4 pads now, I see they are all at the same height on the surface. So these are the timber posts which will be holding up the roof over my deck. This is larch. They're 6-inch square or 150mm square, and they're planed. So larch is very resistant to rot and attacked by the elements, but we will be putting a coat of clear preservative on them. Clear timber preservative, and also a stain on top of that. Nice grain there on the larch, so hopefully the stain will bring out this grain. Here's the subfloor, more or less complete, and nearly ready to have the deck boards put down on top of it. So we actually built this in 2 pieces because it would have been too heavy to lift into place as a large single piece. The ground is higher at the back towards the house there, and lower towards where I'm standing, so as a result there's quite a lot of space underneath the timbers. There's more space as you come towards me, and those have been padded out, which I'll show you in a moment. Also, it's been squared off, so we've measured in an X across the angles, and we've ensured that it's properly square, so that everything will sit on it properly from above and so on. There's a row of noggins, 2 rows of noggins rather, running along. That's to keep the joists straight, stop them from twisting, and ensure there's a uniform distance between them and so on, stop them from bowing. And if we have a look here at some of the padding, in some places I've used concrete slabs, and I've also used some ceramic tiles which I have stuck together with expanding polyurethane glue, Gorilla Glue, which is waterproof and very durable. So I didn't want to use timber to actually pad out the frame to the ground, because the timber could act as a wick to bring moisture up from the ground into the subframe. So by using either concrete or ceramic tiles, I have effectively formed a barrier, a moisture barrier, to prevent moisture from wicking up from the ground below into the timber. So you can see in more detail, in some places I've just used ceramic tiles. So you can see here I have a little stack of 4 tiles. These tiles are small floor tiles. They're about 4 inches square. So they're a little bit tougher than wall tiles, so they can take a little bit more pressure. But also the glue I have in between each layer of tiles will act to some extent as a shock absorber, so that will help to insulate them from cracking under pressure, and there won't be a lot of pressure on them anyway. Quite a good view of the noggins here in between the joists. You can see they're staggered left right all the way up. This is just to allow access to drive screws into the back of each timber. So everything here is screwed together, not nailed. This is just to make it that little bit more secure and keep it tightly held together. It's quite solid now, so you can step on it and it doesn't move. You can see here where we joined together the 2 sections. So as I said, this was built in 2 sections, and we brought them together, and those 2 beams are screwed together in various places along the length. And the whole lot is levelled onto the concrete pads that we put on earlier. These pads will also be supporting posts later on. The posts will support the roof. So that's the subframe. All the cut ends of the timber have been treated with clear timber preservative. So anywhere we cut timber like this, we put clear preservative on it on the cut. The timber is pressure treated as well, so it should be quite resistant to moisture. And anyway, there'll be a roof over this structure, so there shouldn't be a whole lot of moisture in here. And that's about it for the subfloor. I want to show you a small change I've made here. So underneath the edge of this subfloor, there's a gap of a couple of inches between the ground and the timber. So obviously there's a risk that rats and mice may decide to come in underneath that gap and cause problems under the deck. So what I've done here is filled in that gap with some concrete. All the way around. You can see it there. Now, in case there's any possibility that the concrete is going to wick moisture up into the timber, what I first did was I put on this damp-proof course. This membrane here was stapled on to the bottom half of the timber, and it goes right underneath and up the other side, and that's to separate the moisture in the concrete from the timber. And on the outside, to make sure that the timber or that the concrete doesn't bulge out in an unsightly pile, I've just temporarily screwed on this plank here down to ground level, so that'll give us a nice clean straight edge on the concrete on the outside, and we'll remove that when the concrete is fully hard. So the entire deck is covered now in deck boards. You can see here 2 boards that go around the edge. We've cut a 45-degree angle and put a lining of 2 boards all the way along there. That's just to provide a smooth edge rather than having the edge of the deck along this side, consisting of a lot of cut ends of boards. It's just nicer to have a smooth plank edge on that edge of the deck. So to ensure even spacing, if you look down along the deck here, hopefully you'll notice that the deck boards are evenly spaced. So there's a gap of about 6 or 7 millimeters between each board. And the way we made sure the gaps were consistent was I made up these little spacers. So these are just 6mm bolts put through a piece of timber, and when we were putting down the boards we would put each spacer into the gap just like that, and the bolts would ensure then that there was a consistent space between the boards all the way down. The screws we've used are not standard, building screws. They are in fact special outdoor decking screws. I don't know if you can see them there. So these are galvanized, I believe, but they're treated somehow anyway to make them more resistant to the weather. We've also made sure that on the end of the boards running along the end here, that we cut the cut edge here was cut to match all the way down along, so that we've a nice even line all the way down along. So these outer boards here, this one and this one, we'll have to lift these up again. They're only temporarily screwed down because the posts that will support the roof will be going in here. So we'll actually be cutting a section out of these to go around the posts. So we'll remove these boards, we'll mount the posts on the timber, on the concrete pads below, and get them level and everything. And we're actually going to cut a section out of each post. We want the post to actually be flush here with the corner. So the edge of the post should match the edge here and the edge along there. So after we lift these boards here, we're going to cut the post so that it sits down on top of these guys. So there will be, I guess, that's about a 1 3/4 inch. That's a 44mm board. So there'll be a 44mm cut out of the post that way and this way, and the rest of the post will go right down to the concrete level, and then we'll bolt right through this timber here in through the post to hold it in. And we'll also have some angle iron bolted on the inside, which will bolt onto the side of the post and down onto this concrete here as well. So that's the deck boards. It's just been raining, that's why the boards are a nice colour. It looks like the boards have been varnished, but actually they haven't. It's just the rain stopped a few minutes ago, so they're nice and brown looking. So the other thing we did was we made sure that the boards were flush with the concrete step here, and also down there, and that door down there. So we worked our way in. We started out there at that edge, and we worked our way in, and then when we got as far as here, we realised, we had a part of a board, because the measurement from the last full board was here, and the measurement into the step then was obviously less than the width of a full board, so we had to use a table saw to cut a nice straight edge here along the length of a board. So there we are, nicely surfaced deck. Next step is the posts. So 3 of the posts are now installed. You can see there. And let's have a look at how those were actually anchored in place. So if we look down here, we'll see that the joist has been notched into the bottom of the post to give a nice flat finish on the outside. We've got piece of angle iron. I think that's 6cm high angle iron. It's the width at the base is I guess about 5cm, and that's bolted through the post. So the bolts go, it's a threaded bar which we've put right through the post, and the bolts go right out through the joist on the other side, so that holds the joist nice and snugly to the post, and the post is obviously held down to the ground with that bolt that's going into the concrete. So that bolt goes down about I guess 10cm into the concrete and is held in with chemical fixing. We have another bolt here which is going straight through the post and out to the other side there. They're slightly recessed. We're using large washers to spread the force of the bolts. So let's have a look at what's on top. So this is a small piece of the rail which will run all the way across the front here. So that's also recessed into the post, and then the joists at the front will sit on top of that, like you see this one here is. And if we just look back up here, you can see the joist is inset into the post there. We've cut out a piece. We've also cut, I don't know if you can make it out there, but we've also cut the slope at the top of the post. So the top of that post is level with the top of the joist. So the slope matches the slope of the roof. And if we go to the back post here, we can see that both the joist at the side and the rail at the rear of the roof, which is attached to the wall, I'll show you in a moment, both of those have been notched into the post. And in fact, we will be adding another bolt going out through the joist at the side and in through the post. As you can see, there's one bolt going from the post through the rail at the back. So if we look here at the rail on the wall, these have been put in with what are called express nails. So those are 15 centimetres, 6 inches long, so there's about 3 inches of that in the wall and about 3 inches in the timber. There's another one there, and there's another one there. I'll give you a look at one. I'll just find one over here, show you what they're like. Here we are. So here we are, that's an express nail, or also known as a compression anchor. Get the camera to focus on it now, it'd be good. Let me see if we come over here, will it focus? Okay, maybe you can see it better now. So the tip is slightly smaller, that goes into the hole. So that's the size of the hole you drill, the size of the tip. And you bash it in with a hammer, and as you do, the rest of it compresses down and fits snugly and tightly in the hole. And also, as you're hitting it, the head here expands a little bit from the blows as you hit it, and that when you get it all the way into the timber, the head helps to hold because it's wider than the rest of the nail. All of the roof joists are fitted now, and you can probably see there that we've rounded off the ends of them just to give them a nice lower edge. So the roofing polycarbonate sheets will be coming right to the top of those joists out to the edge, and you can probably make out there's a slope, so there's a fall of about 35 centimeters from the back to the front here. The joists have been fixed at the front with these L brackets. Hopefully you can see that one there. And there's a pair of them. There's another one on the other side. And then at the back we've used joist hangers. So they've been cut. The ends of the timber has been cut at a slight angle so that it fits against the vertical edge of the beam at the back. And the same all along. So some of these roof joists have some twists in them, or bows, so we will be putting in some noggins. That's our next step, put some noggins in between them to try and keep them from bending or twisting. Some of them will be at the edge of 2 sheets of the roofing polycarbonate, and it's very important that those ones are in the exact right position because there will only be a few millimeters of play there with the edges of the polycarbonate sheets. So the noggins that we're going to put in, we're probably going to put in 2 rows or maybe even 3 rows of noggins in between will help to do that, to keep them in position. Currently you see there are a couple of planks on top we just have temporarily screwed down. That's to stop any initial movement on the timbers, but we'll take those off. These planks up here, we'll take those off when we put in the noggins. So I decided to add some bracing to these posts at the front because I realised that there was a bit of side to side sway. It was possible to push slightly sideways, and there'll be a little bit of movement at the top. So this bracing at the top of the posts, diagonal braces, will prevent that and makes everything much more solid. So the timber is the same width as the rail up here, and it's secured with 6-inch screws. I don't know if you can make them out there. So they're slightly countersunk just to give a nice neat finish, protect them a little bit from the weather. And there's also some glue on those joints as well, just to make them nice and secure. So we've done that all along the front here, and gives a nice old Wild West look to it, and also obviously adds a lot of structural strength. There's no more side to side swaying going on now. So as you can see now, the polycarbonate roof sheets have all been fitted, and we've got aluminium glazing bars here. These brown bars are at the joints where each pair of sheets join up. There's a glazing bar, which I'll show you in a moment. So the sheeting is 5-wall polycarbonate. So there's actually 5 separate walls, obviously the 2 on the outside and then 3 on the inside. So you've got an area of trapped air, multiple compartments of trapped air in there that act as an insulator, and also there's an X profile. I don't know if you can see it through the foil here, but there's an X shape inside each cell, which adds to the strength. So the back of the polycarbonate here has been sealed with aluminium tape. That's to prevent any insects or moisture or dirt getting in there. And there's also tape at the front, which is slightly different. It's what they call breather tape. It's perforated tape, so that the air that's trapped inside in the compartments in the polycarbonate can move in and out. You know, with expansion and contraction, as it heats up and cools down, that air needs to be able to get in and out, because the back end here is sealed. And it also allows condensation, that if any condensation forms inside in the sheets, it also allows it a way of getting out. So at the edge here, we've got an aluminium F profile, which is used to retain the sheet at the edge. Sorry, we're having some focus trouble there at the moment. So as you can see, that particular the sheet is slightly too short here at this edge. It should go all the way to the back of the aluminium profile, but it's not. So we're going to have to put a bead of mastic down along here just to seal it. Now it's important that you use the right kind of mastic, because ordinary general purpose mastic is bad for this polycarbonate. It reacts badly with it, so you need to use what's called neutral cure mastic for anywhere that you're going to do a seal. So if we take a look at the glazing bar setup, so at the bottom you've got what's called a rag gasket. So that's a rubber gasket that is running along the top of each timber joist. So we've obviously spaced the joists very carefully to match the spacing of the sheets, and the 2 sheets edges are aligned either side along that. And then at the top we've got an aluminium glazing bar with rubber seals in each side of the glazing bar, and that's screwed down along at intervals down along the sheet. That bar is screwed down, and the seals are compressed, not enough to compress the actual shape of the sheet, but enough to apply a little pressure that you'll get a seal with those rubber seals on top. So the rubber seal on top is the primary seal to keep out moisture, and then if any leaks in there, you've got a secondary seal underneath with the rubber gasket that's on top of the joist. Now the reason that the sheets are not closer together is that you need to leave a gap for expansion and contraction. This polycarbonate expands and contracts with changes in temperature, so it's important that you leave a gap between the edges of the sheets. But obviously you need to get that gap sized very carefully to make sure that you actually come inside the seal, so that the rubber seal actually does cover the edge of the sheet. So we're going to be putting more of this aluminium F profile, this stuff here, along the back here. We're going to put another layer of that to seal it at the back, and we'll probably also put some mastic on that to seal that as well. This is the underneath view of the completed roof. So you can see the noggins have been put in a straight line to look like an actual straight row of timber. And we've also done a row of noggins at the front here to close off the gaps in the roof sheeting at the front, and obviously they also provide some support for the joists. We've created a couple of doors, and the reason for that is there's one door here and there's another door behind me at the other side. The reason for that is we're going transparent covers all along the side, so it'll be PVC or something similar to PVC, transparent covers along the sides. So we need doors obviously to get out to the rest of the garden. So we're nearly finished now, and things are looking good. Here's the view from the front. So you can see the plastic PVC brown trim that's along the front of the roofing sheets there. So that's just a U profile that you slip over the front of the sheets, and a little bit of neutral cure mastic underneath it to hold it onto the sheets. You can see the other door over there, and all of the rest of the area here will have transparent PVC panels, which will have zips on them, so it'll be possible to zip up a panel and roll it up and tie it in an up position for a hot day, but then on a colder day we'll have all the panels down, which will keep the wind and the rain out on the cold days. So the final chapter in our deck story is the side covers that you see here. Here in Ireland we get a lot of wind and rain. That means there's a lot of days in the year when it's just not comfortable to sit out on a deck because it's cold and wet. So we had these covers made to surround the deck on the outside, and each panel is zipped, so there's a panel aligned with each post, and each panel is zipped up so you can raise and lower panels. So on a hot day like today, I have the center panel open, but on a cooler day all the panels can be closed. So these covers are reinforced PVC with the transparent sections in the centre. The large windows in the centre are something called flexi-window. I'm not quite sure what that's made from, but they were custom made for us by a company called Clonmel Covers, who did an excellent job. We're very happy with. They came out, they measured up, they manufactured the covers, and they came out and also advised us on how to fit the covers properly so that they're square and neat and so on. So this also obviously protects the timber structure, so there's no rain getting on the timber. You can see here we have battens at the sides which are covered, so timber battens that are wrapped in the same reinforced PVC and then screwed through onto the timber posts underneath. There's the zips, so they zip all the way up. The zip starts at the bottom there. We've had some rain recently, so there's some muck splash on the bottom of the cover there. So I plan to put gravel or concrete slabs along the front here, because the rain drip off the roof is landing there, and then the splashback is hitting the covers. So if we look at the one that's rolled up, they're pretty simple to roll up. You just attach those little clips on the top. You see these guys here, they clip into those, and so you attach short straps onto those clips. There's a clip on the outside and a clip on the inside. You literally open two zips, roll up the cover and attach the clips. It's like a 5-minute job. So it allows us to control the temperature, because when the covers are down on a sunny day, the place gets really warm in here. So we could be talking about 35 degrees on a sunny day, centigrade, which is way too hot. So by opening a couple of covers, we can just lower the temperature really quickly. And obviously we often have the doors open as well. You can see there the doors are open. So that's the end of our deck video. It's been a very successful and interesting project. I hope you've enjoyed watching this, and maybe it might be of some use to you. Thanks. Bye.